What are confounding biases in real-world evidence? The objective of real-world evidence can be to assess the association between an exposure, for example a treatment or management, with an endpoint, which can be an event of interest, such as death or cure, or success of the management. Let's take the example of an observational study in real-world settings, based on questionnaires in which we follow participants who wish to become pregnant. 20 declare practicing sports on a regular basis and 20 with no or little sports practice. They have different characteristics. Some have already had children, others have not, etc. After 1 year, 6 participants in the regular sport group became pregnant, corresponding to 30%. In the group with limited sports practice, only 2 pregnancies occurred, leading to 10%. The probability of becoming pregnant is therefore 3 times higher in the sport group. Let's have a look on the participants with a body mass index, BMI, below 25. 65% of the participants in the regular sport group had a BMI below 25, while only 25% of them were in the limited sport group. In the regular sport group, 38% became pregnant during the year, while it was 20% in the limited sport group. We conclude that the chances are twice as high in the sport group, in this subgroup of participants with BMI below 25. If we look at the related results for the other participants with a BMI greater than 25, there is 1 pregnancy in each group, which is 14% versus 7%. The probability is also twice as high in the sport group as in the limited sport group, in the subgroup of participants with BMI greater than 25. So the question is, what is the real effect of sport on the chances of pregnancy? Is it 3 times more likely when you practice sport without looking at the BMI? Or is it twice when you do sport, considering the BMI category? Well, this is what we call the effect of a confounding factor. The BMI came to distort our estimate of the association between regular sports practice and pregnancy, because the groups are not comparable on this factor and it has an impact on the chances of pregnancy in this example. The confounding factor, BMI, in this example, is related to exposure and is also related to the outcome. This confounding factor, if not taken into account, leads to systematic bias. The crude analysis results on a wrong estimate of the benefit of sport practicing, and more generally, of the effect of exposure on the outcome. In our example, the crude analysis indicates that the chances are 3 times higher when women practice sports, whereas in reality, after taking into account the BMI, the chances are only twice higher. Not taking into account the confounding factor leads here to overestimate the effect of practicing sport. It is therefore important to be taken into account. When designing a study, we have to consider the existence and identification of potential confounding factors in order to be able to collect them, minimize them, and then take them into account in the statistical analysis. Thank you.